Hello and welcome back to the channel where we are building a video game from scratch using Love2d and Lua. Yesterday we got our falling animation working and our player respawn based on our last checkpoint. So that's all good and working. We don't have a good way to like fully escape a pitfall reliably, or it's actually pretty, I just did it, but I don't know how I did it. I think we can still avoid a fall if we go diagonally, but maybe not. Let's see. Okay, yeah, so if we walked straight diagonal, we can actually get over the pit, but if we try to walk straight over it, we do fall. So, oh, well, if we're lined up just right, we should fall. Okay, so it is a little bit janky, but I think it's good enough for what we want. Now today is an earlier stream because we've got tickets for Deadpool coming up here at 7, so I'm trying to stream before that so we can just have a nice evening out. And I was thinking today we could dive a little bit into a particle system for some weather effects, because part of the game is, you know, there's certain biomes, right? So like the water biome or the desert biome is over here to the right or whatever, and I want it to be, the game will kind of prevent you from exploring certain parts before you're ready to go there. So there is a sort of a linear progression to the story. So I want it to be, if you try to walk into the sand biome before you've finished the forest biome, that the sand, there would be like a sandstorm effect, and it would be pretty heavy on the first frame, but then on the next frame it would be so heavy that you can't actually move except go back where you came from. So like I want to do like a sandstorm effect. I want to do like a thundery and rainy jungle effect. It would probably just be thunder, and then we add the lightning effects and the sound and stuff. And then there's maybe a snowy one for the mountains, because the mountains are up here. We do have, like, this red is supposed to be like a lava biome, so like a mountain and some like lava flowing and stuff I think could be cool. And then the blue is gonna be the mountain and snow biome. So I think let's dig into the particle system and just try to get some basic like rain happening. And if we can get some basic rain happening, then we can adapt it to be like, okay, well now instead of rain, it's snow because it's white, or now it's sand because it's sand colored, or now it's soot because it's black or whatever from the mountain biome. So I think we're gonna do that. I'm going to get rid of this pit count so that we don't see that anymore, and then we'll get started trying to build some weather stuff. Now we do have a particle system already in place for our spell casting, and I'll show what that looks like. Right here, we need to comment this out. So right now we do have a particle system for our spellcasting, and it emits these little blue particles once we're in a successful spellcast. So we're going to be doing something similar. We can see what we did with that particle system and how we pulled that off. We do have to define a particle system first. So this is what we did. We said love.graphics.new particle system, and it needs a picture of what particle to spawn. And in this case, particle is literally one black particle, I believe. If we look at where we define this particle, it looks like it is graphics particle PNG, and I'm pretty sure it's just a black pixel. Let's go to graphics and we'll find particle.png. And oh, it's a white particle, I think. Wow, since it's one pixel, I can't even like Oh, there we go. There we go. Okay, so it is a white pixel with a little bit of like dithering. So I think that is a byproduct of Windows trying to blur it out, because I think it's really just one white pixel. If we look at the details, yeah, it's a 1x1, so it's just white. So I'm curious how we're actually setting the color to be blue for the spellcast. We can see maybe how we're doing that. So we set a spellcast entity and it gets a particle system, and we get one for each of our spellcast entities, and the second argument there, it goes, first argument is a particle, which particle, and then the second argument is the number of particles. So we're doing 400 for this spellcast. And then if we continue searching on into this P system, we can see that we are doing a move to. Okay, so that's to move the emitter so that it's in the center of the object that it's coming from, I'm pretty sure. And then these are the couple things that we need to worry about. An emission area. So that is where the particles are coming from, a particle lifetime, an emission rate, a linear acceleration, and this is where we're doing the colors. So these numbers here, so this is 0 on the red value, 1 on the G, 1 on the B, 200 out of 255 on the alpha channel. So that's like a cyan blue color that is a little bit transparent. And then the second 4 numbers are what it fades to over time. So it fades to a darker blue because it is no red, no green, and a little bit of blue with a 0 on the alpha. So it should go from a cyan color to a dark blue that fades all the way throughout. So that's what this color is. But, you know, we would switch it up for either sand or rain or whatever we decide to do. And then it looks like these are the main functions we're using for the particle system, as long as we update it and then render it. So it will be simpler than our spellcast particle system in the sense that there's only one of them, and we can set it to, you know, have a wider emission area. So let's start playing around with. Would we put this in a weather class so that we can? I don't know how we would do it. I just like drank a bug in my water. I don't know what it was. I just drank something chunky, man. that was awful. I drank something chunky. All right. That was enough. That was enough excitement for today. I think for now, maybe we'll make. I think. Because if we think about it, we want the particle system to only exist over the current map, right? Like if we're on a map that doesn't have any water or snow, then we would want no particle system to be updated for the weather. So ideally, we would say maybe we would put the particle system instantiation inside the map itself. That is kind of making sense to me, or it depends if we want the game to have weather not dependent on what map it is. Like let's say there's just like a 1 in 4 chance that any given jungle tile is raining, and the how bad it's raining depends on random chance or something. Dude, yeah, so yeah, my girlfriend's hoping we get the popcorn bucket, so we're going early. I think it's a 7:30 show, and we're gonna be leaving at 7 so we can get the popcorn bucket. Yeah. So I guess we get to decide, right? It's our game. I'm trying to think of what makes most sense. In terms of scalability, but maybe we just go ahead. Well, yeah, I'm not thinking if we make it like, let's say we put it in a weather class and the weather accepts a property of what type of particle system it is. So we can say, go ahead. Yeah, let's put it in a weather class. And then what we'll do is we'll just put in, we'll make an instantiation of a weather class using whatever particle system in our current map. And then we can have it where either we spawn, hey, every map 1-1 is a raining weather instantiation, or we can do it where we manipulate the weather instantiations based on certain things like how many biomes have you cleared, because over time the what do I want to call it, like there's a big theme in the game is like equilibrium with the environment. So it starts off very hectic, like it'll start off in a rainstorm, it'll start off, there's like lava, there's crazy snowstorms and sandstorms, and as you clear out the biomes, you achieve a little more harmony in the world. So the weather will get nicer and nicer as you progress, and as it gets nicer, it allows you to explore the rest of the biomes kind of one at a time. And then so that's why I'm thinking if we put the particle system into a weather class and make sure that weather class has parameters to tweak how violent the particle systems are, then that might be a good way to go about it, instead of hard coding it in based on which map number we're at. So that's the kind of thinking for this. So let's get started. But yeah, I agree, Katron. My girlfriend's hyped for it. She painted her nails and everything. She's got yellow nails, and she's got like 3 black nails in the middle for Wolverine. It's gonna be cool. Okay, so it looks pretty simple, right? We need let's give ourselves the weather class, okay? And we'll make a weather class. Now, how we make a class in Lua, it doesn't come with Lua, but we do have a class utility we're using. So we can say weather gets class, and we do curly braces like that, and then that allows us to define our functions for the class, and we can say weather init, that will get called once upon initialization. Then we will need a function weather update so that we can update our particles positions and everything, and that takes in delta time. And then we of course need the last, which is render. So this is what boilerplate class looks like in Lua, and in game dev in general, right? So like, are you not a big Deadpool fanboy, Katron? What's your stance on hero movies or superhero stuff? Yeah, let's go find the particle system. And we will need this release, I believe. Well, I guess it depends, because how we'll be calling it. But we should have this create particle system right here. So what we'll do is we'll go to our weather, which we'll add into our, and you know what? I'm gonna clean up our thing here. I don't want a lot of these. Well, actually a lot of these are useful. Let's just add weather into our harpoon so we can easy access it. And we'll just do that like this. Leader A, and now weather's here. And what we can do is if we put weather up here on one of the 4, we can hop to it with our hotkeys. So weather is now one key away using harpoon. So we can just hop to our weather class anytime. And what we should put on our other one is the other particle system explanation, which we have it in our scene. No, that's not right. P system. Yeah. It's the map. Okay, so we'll make sure that the map is up here next to our weather. And what this allows us to do is to hop between those two, just like this. Map or weather, map or weather. So we can kind of get examples of both. So I'm just going to snag the examples of our particle system for our spellcast, and then we'll go about tweaking it. We just need a sort of example of how to, the things that we need for the particle system. So we'll go over to our weather and we'll put all of this in the update, and we'll change all this, of course, but P system. Then we need the update, and then we need the render. And our render for the P system for the weather would be a lot simpler. It's just one thing. It covers the whole screen, right? So it should be simpler than this. But we do, yeah, look at this. We're drawing the particle system at its X and Y position, which I don't know if that's absolutely necessary. I mean, if we look at where that gets set, we don't give it an X and Y position, so I think that might be, I don't know. But let's see. Let's try to get it working, and then we'll see. So let's for now we'll just assume that only rain is the only weather particle system. So what we'll do is we'll say that this weather class is itself a particle system, and we're gonna call it self particle system gets a new particle system, and then let's just try to get the same exact particle system rendering. So we're gonna say the particle system, we're setting the emission rate, we're setting the lifetime, we're setting the emission area, we're setting the set linear acceleration, and we're setting the color. And then all we do is draw that particle system at its own position. I don't know if that'll work, but let's give it a shot here. We might need to set, oh no, we do set color in the update here. So we need 3 things now. We need to initialize our weather particle system. We need to update that particle system, and we need to render it all within our map. So let's go, or the play state. It depends. Depends how we want to do it, but for now I'll put it in the map. So what I'll do is I'll say, we do have a particle system table, but that is holding the particle systems for the spellcast entities. So I'm just going to make a self.weather, and it's going to get a weather instantiation. Now we do need to pull this, we do need to require where this weather is, which I want to say it's right here. I think we can just say require weather here. No, weather not found. Okay, we need to import this correctly, which, what just happened there? Weather, require weather. Let's look at our file explorer map, and it looks like weather is here, right where our maybe it needs a capital W because our weather is right where our map is, so we should just be able to require it, but we're not. Weather.lua. Okay, so I think what we might need to do is, and it should be here anyway, it should be in our dependencies, and we should be able to just go, if we go to our dependencies, we can go and import it and require it. Oh, as I delete stuff. That's the tricky thing about Vim is like Control D is scroll down, but normal D is delete. So I accidentally deleted, or it's easy to accidentally delete stuff. Okay, so I think it's right here. We have to do this. We require source weather, and then we should have access to using weather. And we are no longer crashing, so that looks like it worked. So let's go, to our map. Now we have a self.weather in our map, so we need to update this with delta time. So we'll just go to our update, and we'll say self.weather, and we run our update on it. We pass it in delta time, and then we have to render it. So we'll go to our render function, and we'll just plop it in there. And this is just to test it, right? Like, this isn't like where it's gonna live, but it's gonna be, self.weather : render, and call it like a function. So now our emission rate is a nil value. So it looks like weather does not have the info on the emission rate, which means our weather is being declared after, in our dependencies, our weather is declared after we describe what our constants are, I guess, but I thought, no, we've got constants up here. So if we look at our P systems again, and we look at the example that we do have, where we spawn it, like right here. See this emission rate? Let's find this emission rate. Emission rate is here as a local variable. So since we want an emission rate to be different depending on which particle system, we'll just give our weather our own emission rate, and we'll probably call it rain emission rate or whatever. So we could have specific things. So for right now, we'll just give it emission rate of 80, and we don't have a spellcast entity count. So for whatever reason, my NeoBIM just gets jacked up these days upon a crash. I don't know what's going on with that. But yeah, we don't want to divide by the amount of spellcast entities we have. We want to just give straight up 80. Okay. Now I don't see it, and it could be off screen. So let's move our particle system, because we don't tell it where. We set an emission area. Let's try to move it. And then if we can't see it still, then we can figure something else out. Move to. So the first thing we're going to do is just move it to. And what we're going to do is we're just going to say move it to 1010. I don't know. Just move it to 1010 and let's see. don't see it. And we are rendering it, yeah? Man, that is so jacked up. So if we cancel this, look at all that junk that just gets left on the screen. Why does it do that? Okay, that's a bug if I've ever seen one. Okay, so we're not seeing it. We are initializing it and rendering it in our map class. We're saying weather gets weather. And then our weather has a particle system. We move it to a position, we set its emission area, and then we render the particle system. Self.psystems. Okay, yeah. Let's put 1010 on here and see if we see anything. Because the thing is, all of these particles float upwards because they're like fire. So if it's spawning at the top of our screen, it would be floating up and then we can't see them. So that's not it. I'm going to pull up particle system documentation because that helped us out yesterday. So, Love offers a new particle system. We give it the image, the number of particles. We set a P system equal to a new particle system. That's what we're doing. We have a new particle system and we're setting a P system to it. We set a lifetime. And then, why is the draw before the update? Anyways, that looks right. And that's the same code. That's the same code from our spellcasting particle system, so it should be appearing. Let's check in our P system. Oh, it's actually weather. Weather update, weather render. Weather gets weather class. Okay. So yeah, I mean, we're seeing our, like, if we were to put a print saying that this is weather, then our game should show that. If we put an S here. Okay, that's weird. We aren't seeing it. Oh, I just figured it out. Okay, we're doing it. We're rendering it right before we render our map and anything, so the draw order is jacked. So what we want to do is render the particle system very last on top of everything else. And then now we can see this is weather, but we aren't seeing our particle system. So, what's going on? If we go to weather, let's take out this. We give ourselves a particle system. As long as we have access to this particle, which we should in our dependencies, I would think. We don't. Okay, so we need to make sure our particle is global to our application, which it bugs me that it wouldn't throw an error when we try to render something that it doesn't have access to, but it does not. So we will go pull it from our P system. Where is it? Particle. We should have just searched for particle. Okay. We have it right here in the entity class. It's just weird. I think what I want to do is take it out of the entity class and put it in our dependencies as a global particle. And then we shouldn't crash. Well, we do. Bad argument 1 in entity, because we don't have access to particle. So, you know what? We'll go back to our entity class. We'll give us that particle. And then we shouldn't crash. And then I'll just import the particle into our weather class as well. And then now we should be able to see our particle system, and we still don't see it. Now, let's say, hey, this is particle 2. Maybe in case there's something weird going on with the global variable. I don't see why it would. But we're setting the particle system to take in that particle 2, and we still don't see it. We are rendering it last, so we should see it. Now we can try putting it in our, it's in our map right now. Self.weather render. Okay. If we look at how we're rendering our other particle systems, okay. So how we are rendering our particle system is actually with a draw function, not a render. But the render will just call the draw function, which is in our class, like here. So I don't see why that's an issue. Let's try to plop in 10 and 10 right here and see. We are, well, let's see. Still don't see it. This is CPU-based PS. I don't know what PS is, but Lua, I believe, only runs on CPU. And it's running on single thread, I'm pretty sure. But our game is Game Boy resolution. Oh, okay, gotcha. Yeah, this engine, as far as I know, doesn't have such easy access to GPU based stuff. And it's a really simple Game Boy game, so I don't think we're gonna need more than CPU based stuff. I'm still a beginner game dev, so I'm not super versed in any sort of GPU coding. So that's in the future, but definitely not where I'm at right now. I can't even get my freaking particle system to render. So like the geckos have their own particle system, and that works great. Let's see how we're doing that for the geckos. Okay, we update the particle system here inside. Yeah, I mean, is that not what we're doing? Oh, we don't update it. Let's make sure we update it. Oh, there's our particles. Cool. Sweet. So if we get rid of the this is weather, we can see our particles. So that is the particle system that we took from our spellcast The only difference is that we're changing how many are being emitted based on the number of spells that are around us. So it does look different. But as far as even like fire or something goes, like that looks pretty cool for like fire or something. And it's mainly going upwards, right? And then some are going out to the side. So let's see. I kind of want to add like a particle system render mode where I can toggle a screen that kind of makes everything gray or something and just shows the particle system so that we can debug it a bit better. So maybe before we do this, if we do a love.graphics.clear, let's see if this will work with red, for example, and we'll say 255 and 255. Okay, cool. So what I want to do is to be able to toggle this with a button press. So we can just say if love.graphics.keyboard is down, and we can just do 3, then go ahead and set our clear. Yeah. So let's do that just so we can see is it love.graphics.keyboard? Love.keyboard? Okay. Cool. So now we can kind of like see our pixels a little bit better, right? So let's move our pixels over. Well, actually we need to change, since we're doing rain. What the heck? Since we're doing rain, we need to set the emission area to be the length of the screen. So we don't want, and actually I'm gonna have to look up this emission area in Love2d so that I know what parameters I'm looking at. Set emission area. Okay, so let's pull up the forbidden texts. Set emission area, distribution, dx, dy. So distribution, normal. What the hell is normal distribution? Normal is a Gaussian distribution. Uniform is a uniform distribution. Okay. dx maximum spawn distance from the emitter along the x-axis for uniform distribution. Okay. And then yeah, let's plop the particle system right in the center, and we'll mess with the area distribution so we can try to wrap our heads around what those things do. So if we move this to, what we can do is take our screen width limit, and we can divide it by 2, so the center on the X, and then a screen height limit, and we'll put it divided by 2, so it should be right in the center of our screen here. And then let's set, that doesn't look so center, but let's change our color here to be gray. So we'll just give ourselves like 100, 100, 100 maybe. Okay. Sweet. So yeah, we can see the particles much better now. So let's maybe take off our set linear acceleration, and then we'll modify the distribution and see if we can glean anything from that. So let's take off our linear acceleration. Okay. So it looks like they just spawn and die and they don't move, right? Because we're not setting any acceleration. So it's taking our starting and ending color and just kind of drawing them and fading them. So let's look at the emission area. If we change this, like what happens if we say 0, 0? Does it show anything? No. Or it shows 1, right? So let's give it a 1 on the X and see it, or actually it's not even X, it's just, wow. Okay, so that's like how long it is, I guess, and let's see if this is like how tall it is. Yeah. So it's like, but one unit? What is the one that it's changing by? If we look at the, did I minimize this? DX spawn distance, maximum spawn distance from the emitter. So why does 1 give us like 6 pixels worth of difference? Like, I don't get that. Because if we were to put 10, how big would that be? See, why is 10 like that far, you know? Because ideally I want to say give us, you know, the spawn distance should be a whole screen worth of pixels. So what is 10 from the center? Like, it would kind of make sense if 10, you know, if dx is 10 here, it would take whatever we move to, so like our somewhat center screen, and it would go 10 to the right and 10 to the left, giving us a total of 2 pixels, or 20 pixels. But if that's the case, then 1 should just give us 2 pixels, but it is wider than 2 pixels. So like it looks like it's 8 pixels long. So that's what I'm not so understanding. If we divide this by 8, will it give us... Like, I'm just literally just playing around. Like, see, this is what I expected. If I were to give it 1, I would think it would give it like 1 pixel on the left of us and 1 pixel on the right of us. So like if we were to do screen width limit here and then divide by 8, it would be like about how wide the screen is. See, that's so weird. I don't know why. Yeah, let's change it from normal and see. That's a good idea. So there is a uniform distribution instead of a normal. So we'll try that and we will see what that looks like. Oops. What just happened to me? What just... I just deleted our code there. Okay. Emission normal. Let's go emission uniform. Okay. Yeah, it's a lot more contained. But what's weird is, why does 1 on the DY give us 2 lines of pixels? And 0 gives us 1 line of pixels. That's weird. Does that mean 0? Okay, let's see. 0 on the DX just gives us 1 and 1. So if we do 2 or 1 on the DX, how many pixels is that? It's like 2 pixels. Okay, well, 2, would 2 be 4? It looks like it, okay. Okay. So we would basically just want whatever the screen width is divided by 2, and that should give us a screen width amount of pixels. And then width, it's a little off. It looks like our X is off. I think our width limit might be a little screwed up. It should be 160. So let's just try to put that in. 160, okay, divided by 2, so it'd be 80. Let's see. Okay, well that looks the same. It's just that maybe our move 2 is jacked up. So let's go back here to our move 2 and yeah, this, I don't know why this is off. But if we hard code this right to the center, it would be 80. And it is 8 tiles tall, so 8 times 16 divided by 2. $64. So 80, 64 should give us right in the center. At least for testing, right? So like, yeah, it still looks... doesn't go all the way left. Yeah, I'm wondering if I screwed something up with this screen width limit. But I really don't know. Anyways. This is just, you know, this is just a playground for the particle system so that I can see how this might be working, and it's not that we want to move this to be over to the left a bit, and we'll see. Okay, so we're going off all this, we're going off, you know, the whole screen. Yeah, I mean, I don't know. I would think that giving it the right, like, if we move it to, oh, well, if we move it to 0 on the X, okay. Oh, okay. Well, see, like, that should be... Because if you think about it, like, 0 on the X is kind of like, you know, starting at the left, but it's cutting some off. Because if we go 80 on the X, we still see stuff, like, it doesn't get cut off till, like, right here. So, like, the particle system is kind of building it out from a point, I want to say, like from a center point, and every time we add distance, you know, it adds and makes it longer, right? So, like, if we had 20 here, the center of us, it's still off center, but, like, whatever reason why that's off center, I don't know why that's off center. It would be this. But we could instead say, hey, move to 0, and now when we run the game, we start at the very left, and we can increase it over to the right, but it depends on the type of logic we want to give the particles. So let's set our linear acceleration again, and let's see how we might make this look like rain. So I'm going to pull up the set linear acceleration so that we can see what these values are, because there's a couple. So we have I'll just leave this documentation in the back here, and then we can just keep it up while we code. So we can see a x minimum, which is the minimum acceleration along the x-axis. So a -5 would be the minimum acceleration. That would mean we would be moving left. So if we're making rain, we want it to move one direction at a time. So we might want to feed this value, a value that changes over time, but stays consistent with one another, because we don't want some particles going left and some particles going right, but we want the collective particles to sometimes be going left and sometimes be going right. So let's just try to get y minimum. Let's see, the second argument is y minimum, minimum acceleration along the y-axis. So if left and right is the x-axis, up and down is the y-axis, so the minimum we want to go upwards is -20. So let's change this to a +60 so that it will be falling. Or the minimum would be maybe 30, and then the maximum might be 60. And then the minimum or the maximum x might be also -5. Because we want consistent direction for the rain here. The showing is at 7:20 and we're leaving the house at 7. So I've got 40-ish minutes to try to knock something out. Ooh, look at that rain. It looks more like snow, right? But, oh, that's awesome. Yeah. Okay, so I think the first step is like, one, get it as long as the screen, right? So we'll get it as long as the screen, we'll move it to the top of the screen, we'll change its color, and then we'll worry about shifting it over time so it looks like the water is kind of changing based on the wind or something like that. So let's first get our system. We want to move it to the top. So we say, and I think if we just leave move to out, it might spawn up at the top. Let's see. Okay, well, what the fuck? Why would it spawn there? Like, why would it spawn there? But if we move it to 0, 0, does it then go to the very top? No, it does not. I don't know why that's the case, but why would 0 not be at the top? We'll have to figure that out, because that doesn't make any sense. But now at least we can kind of see that the rain is coming in from the top there. So let's set the color for the rain. So let's go to our set color, and we will say that we are trying to set perfectly blue, RG, 0 for G. Let's put 255 for blue, so it's like super blue, and 255, so fully opaque. And then we don't want to fade it to clear, but we might want to fade it a little bit. So like maybe we do 200 out of 255, but then the end color is not so much strong blue. So let's see that now. And it looks very dark, and it's very dark because this, well, RGB, yeah, it should be not that dark. But let's get our emission area to be the width of the screen here. Okay, it looks like snow, right? We need to increase. They're turning off too soon, so we need to increase the lifespan before the despawning, and then also rack up our emitter. So we can have a particle lifetime of maybe 6 seconds. We can boost it so that it falls faster, so it's more like snow than, or more like rain than snow. So let's say the minimum Y is 80 and the max Y is maybe 150. And maybe we'll do actually 100. And then let's give this a -10 and a -10 to give it more of an angle, just to kind of see. And yeah, see, and we want kind of like clumps. What are GPU stats when you run this particle system? What do you mean by GPU stats? Just like what my GPU is actually doing? We can pull up maybe NVIDIA and see. Because I'm pretty sure Lua just runs on the CPU and it runs on one thread, so it shouldn't really be touching the GPU much. I don't even know, is there, or Afterburner, right? Afterburner. I don't have Afterburner installed. I'll have to do that so I can pull up some GPU stuff, but I believe this is just CPU. And if we go into our settings here, what I could do is turn this off and toggle this on, and I can show you that the game is actually that tiny. So like this is how big the game actually is. It's just Game Boy resolution. And then we're using a library to scale it up. So it really is like a tiny amount of processing for my 8-core processor or whatever. So it can totally handle it. I'm still not seeing blue though. So we want to make sure we're seeing blue. Let's see if we set this to 255, does this change the color? Because also by the time they fall, they're a different color, right? They're closer to black. So like, it just looks black still. Oh, you know what? We're setting the... No. This is a little weird. I would think... Let me see if we get rid of the clear if we get blue particles. We don't. They're just so dark. So I'm going to pull up RGB picker so that we can get better colors. So if we want rain to be maybe like this color, that is 130, 229. And we'll give the fade color the same, just so we can see. It still just looks black. What is this? If we don't set color, what does it appear to be? Red. Okay. It might be when we go in our map, we might have to flush our color before we render it here. So like maybe I have to do a love.graphics.set color, just get white, and then maybe, I don't know, we'll be able to see it better. Or we'll be able to get the blue actually, so like, let's see, that should be white. Okay, and then now, if we turn back on our set colors in our weather, maybe they'll be blue now. They are. Okay, so maybe we just need to flush, maybe we need to set color to white before we do this. So like, I don't like that we'd have to set color here. So maybe in our weather class, we say before we render, set the color, and then we'll clear our screen here, and then now we should have blue rain even when we hold that. Okay, cool. And then we can toggle this to be black because that'll be easier to see the rain. So let's add this to be like, you know, some low number. And then it's still a bit too bright blue. Oh, that was not right. Why was it so bright? It should be black. Okay. So we need a lot more particles, right? They probably need to move faster because it doesn't quite look like rain. And then ideally, it kind of sways in the wind. So we can do... Let's get the particle number fixed first. I don't get why particle system at 0, 0 is not off screen. I don't get that. I don't get it. Because even -5 is like still not off screen. Okay. Let's speed up the rain. So minimum is 150, maximum is 250. And we'll say the X sway is a -15, and we'll see what that looks like. Nice. And then let's just speed this up, or more particles, right? So like, it should be, yeah, it should be windier, right? Like it should be almost going, you know, like a, I don't know, almost like a 45-degree angle falling down. So let's boost how many particles we get. Let's just double it and see what that looks like. But I think it might be under the emission rate instead of the total. This is like the max particles. So I think 400 might be okay for the max, but then under the emission rate, we want, instead of 80, maybe 200. But let's see what the 400 looks like, just out of curiosity. Okay, so like, you know, it dumped a lot, and then it calmed down. Now, another thing we might want to consider is, like, look at how when we walk from screen to screen, it kind of, you know, it'll start empty, and then it'll dump all the particles. So one thing we might want to do is pull our particles out of the map and into our scene, so that it doesn't do this. Like, it would actually, the rain would carry over onto the next scene, right? We don't want it to kind of start from nothing and then start raining, because it would have already been raining by the time you got in that scene. So we should have it outside. But I don't like how it kind of dumps all at once and then finds a stable rate. Let's see what normal distribution looks like now that we've got some more particles. It still does that initial dump. And we can turn down the lifetime back to 3 now that we sped it up. I think we won't have that issue. Wow, this is wild. I just fell in a hole. Oh, what happened to me? Okay. This, you know, this is like not looking terrible. It's just that once it starts, it kind of dumps all at once, and then it kind of finds like a consistent time, and I'm not sure what's causing that. But ideally, you know, I think we want more rain, and we want them a darker blue, and we want them at a steeper angle. So let's do that. So darker blue might be 100 and 209. And a faster speed might be, well, the speed looks okay. I think we just want a bigger emission rate. So let's give ourselves 600 and see what that looks like. And then we'll say also the difference here. Maybe we say that this is, no. It's this. Let's give us 45 here. Okay. Yeah, I mean, it still should be faster, I think. Like, ideally, it looks... I think we should make a new particle of rain stacked, like 3 pixels, so it's not just 1 pixel, because as rain falls or whatever, in our brains, at least I imagine it like, you know, a line. Even though it's a drop, like shutter speed of a camera when you take a picture or whatever would show that it's like a line to give it some motion blur. So maybe we make a new particle that is just 3 pixels tall, so that it can be, let's just see what that would look like. I mean, this is, you know, people would say, oh, look, it's raining. So maybe it's okay. It does start off a little too slow. Move particles up so it gains acceleration. Yeah, I think that's a good idea. I don't think it, I guess, would it start? Yeah, would it start at this acceleration? Let's do that. That's a good idea. We'll scoot it up 50. We'll boost its particle life cycle to maybe 4 or 5 seconds. And then we'll give it a slightly higher starting speed, because I do like the look of the acceleration. But yeah, let's see that. Whoa, there we go. That is looking better. Yeah. Yeah, you know, this does look better. Now, ideally, we would change the direction so that it can go left sometimes and go right sometimes. But I don't know. This is pretty good. I still think it's a little too bright, and we also need to move it outside of our map and into our scene because we want it to carry over, right? We don't want it to be map dependent. Actually, how would we do that? We kind of do want it to be map dependent because you would get a different particle system depending on a different map. So I'm going to have to do some thinking about how we trigger that upon certain biomes. But yeah, let's do a little bit darker of a blue. You know, it's looking like rain. Like if I'm looking at it, it looks like rain. Like I get it. So yeah, let's do a little bit darker. I thought that would be darker. Why is it not darker? That's not right. Okay, well. That is darker. See, it's that initial dump is what's kind of confusing me. Like I don't get why it's so fast. Because if we change screen here, it's like you get that initial dump and then it kind of stabilizes. It's looking pretty good though. Maybe a little darker. I do have a global scene. It's just that we want a different particle system depending on which map we're in. So I can pull it out so that it carries over through scenes, but we also have to have some kind of system for turning it on and off depending which map we're in. I still gotta kind of wrap my head around how to do that. Yeah, I think we can afford a bit more on the angle, but altogether looks pretty good. Yeah, maybe we can do 55 here. Okay, so maybe we can work on getting it to sway like it's in the wind, right? Because right now it's hard-coded at this minus 55. So if we can get a tween value to kind of cycle it from left to right as if it's kind of, you know, being pulled by the wind, that could be cool. So let's try to put in a value here, and we'll call this like wind angle or something. And then we can declare wind angle, at least upon the init, or up here we can say wind angle starts off. See, yeah, I don't know of a good way to do this. We can say, let's start it off at minus 55. And what we'll do is we'll also have a boolean to toggle counting it, right? So we'll say if our wind angle's increasing, or I guess it would be decreasing. Let's say increase is false. So let's say if we're not increasing, then we would decrease our angle by adding a value to it. And let's just see if that changes the angle over time. We'd say wind angle gets wind angle modified by delta time, and let's see. I'm not really seeing it change. Okay, so look, we put a string here, we'll call it wind, and then we'll concatenate the actual wind angle, and we'll print it up at 0, 0. We'll do that after we clear the screen. Oh, it is just so slow. Changing the angle so slow. So like we can scale delta time maybe. Instead of delta time, we can say, how about by 1? Yeah, there we go. So yeah, ideally we have something like that, except it goes back down. Wow. Dang, yeah, that's getting crazy. So we can say something like You know, if our wind angle is greater than 400, then we now become increasing. So increase becomes true, or whatever we want to call that. Increase becomes true. And then we can say else wind angle gets our wind angle minus a 1. So we change it in the opposite direction. And then we can say if our wind angle is smaller than 400, then we would want to become not increasing again. Oops. So increasing gets false, but we also have to reset our value because we're going to pass it. So we're going to set our wind angle to be equal to 400 so that we don't get stuck, and wind angle actually smaller than negative 400. So we're going to cycle between those two extremes. Then we're going to set it back to minus 400, and increasing is false, which means we would then switch our angle. Let's see, we're going to go up on the wind angle, and then it's going to hit 400, and then it's going to swap down. Sweet. Then it should go left. Yeah. Nice. Yes, yes, yes. Sweet. Yeah, I think 400 is pretty good. We might want to scoot down the particle system a bit, or make it a little wider so that we don't get nothing on screen for the extremes there. Because like right at 400 there, we don't get any rain at the bottom. Well, actually, there we did. So maybe we just scoot our particle system over to the left a bit, or to the right a bit, so that right here at the negative 400, actually, yeah, that wasn't too bad that time. But yeah, let's see how this looks. So, yeah, it looks like it's just changing directions. Sweet. Yeah, you know, maybe it should be a bit slower of a change, but I also don't want it to be falling straight down very long. Like, I don't like how it looks when it falls straight down. Like, that's when you can see the code. It's like, oh, I see it. It's just going like this. And then like, so I feel like whenever it goes straight down, it's kind of revealing itself that we're just swapping it from negative 400 to positive 400. But yeah, I don't know. It's definitely kind of cool. Like, I do like it. I like that it sways like that. I think we need more, and we need a darker color still. So let's go here and we'll say, yeah, we want a darker color. Why is it so bright still? Like, if we say 1 on the blue, it's dark blue. But like, really 1 on the blue, is that strong? That's too blue. That's too blue. And then now it looks like cyan, even though we're like hardly... Or is it really... Maybe we've got to add the out of 255. There we go. That's darker. Okay. So, yeah, let's give ourselves a decent amount of blue. So we'll go maybe 50. And then maybe 10. Should be a dark bluish. Yeah. Should be a little more... Actually, I kind of like that. Yeah, the bright parts are kind of offsetting, so maybe less bright. Because like if you imagine a kind of like we can add another layer of animation. Yeah, I wish it would rain too, Katron. We can add like another layer of weather, right? That is like either fog or lightning that flashes every once in a while. But that paired with the sound effects, paired with this looking, that it'll sell that it's rain, right? Yeah. So I think we'd want to tweak this so that maybe all we do, instead of tweaking from left to right, we tweak it from like 20 degrees to 50 degrees or something. So it's like one direction, it's kind of waving in there. Because when it switches directions, I think it just looks a little weird. So maybe we'll tweak it to do that. But for right now, this is kind of cool. Like I like that we're kind of just proving that we can swap it back and forth. I think we want more rain though. Let's just double how much rain we've got. So we'll set our emission rate to 1200, and then we'll put our particle system with a max of 1200, and we'll see how crazy it is. It doesn't look that crazy, to be honest. Yeah, I don't know, it looks less like rain. It looks more like just dots now. Yeah, I don't know. It looked better at 600, I thought. Okay. I like that. Yeah, that looks pretty rain to me. Nice. That's awesome. And we don't have any scenes that like look good in rain right now. Like we don't have like a murky kind of pond scene that this rain would look good in, or a jungle that has like dark dark leaves or something that this could look cool up against. And the sound effects will really help sell it too, because it's like it doesn't look like rain when it's on a sunny grassy plain, so building a scene that rain will look good at will dramatically increase the sellability of how much this looks like rain. But like if you imagine like some thunder striking, and some flashing, and the rain sound effects during this, like this starts to feel a little more epic. Nice. Yeah, I'm liking that. So we added ourselves a weather class, and we're updating in the map for now at least. And all we do is update the weather. Oh, we've got to add this for tracking, and then we can see our get diff, which maybe I jacked that up. But we added the whole weather class, and we've got only rain, but ideally we're gonna have sand and Pompeii and maybe wind, maybe snow, or definitely snow, but maybe wind, maybe like an intense wind animation, which would be different than this particles, but we'll get building that out. We'll say added rain particle system. Yeah, not too big. Yo, Salto, how's it going, dude? Are you just stopping in? We're wrapping up because I'm about to go see Deadpool. But we added a rain particle system to the game today, so we've got rain kind of coming in and being pushed by wind. It doesn't look so great because it's like on a bright day, but if you imagine like a swampy area or something, and then we've got the ability to fall into pits now, so we can get hurt by falling into pits. So it's coming together. And we're going to be adding, snow, some ash for the volcano realm, or for the lava biome, whatever I call it. But yeah, it's looking pretty good. I'm happy with the progress. Yeah, thanks, man. I appreciate it. And then I'm hoping we can raid out to somebody who's working on game dev stuff. So I'm just peeping on someone who might be working on game dev stuff. And it looks like Quellis might be doing some stuff. Let's see. Yeah, so Quellis is making some Godot game. So we'll raid out to Quellis. But thanks everyone for watching. I'll be back tomorrow and we'll get some more particle systems. Before this week, I will be recording the channel trailer for the game and for my Twitch channel, so that should be fun. But I hope everyone has a good night, and thanks for watching.